This is a topic that doesn't seem to go away. Why in the world are embalmers still seeing clots? Now, let's be clear. This is a scientific discussion. I'm going to be doing some scientific extrapolations here. This is not confirmed science. This is just me, after all the years of looking at this, trying to think of explanations to make sense of what embalmers have been seeing. If you're new to this conversation, you are way behind in terms of what has been happening. And the problem is that embalmers have been seeing really unusual clots since late 2020 into definitely 2021, and it's still occurring. Now, one of the people who I've spoken to in the past, Richard Hirschman, he's an embalmer. It was his research that led to the production of the documentary Died Suddenly. And I think that because of that documentary, it caused people to try and ignore it because it just seemed like some kind of strange anti vax kind of program. But in the midst of it, they missed a critical question: are they actually real? So, over the last few years, and as well because of the tireless work of Tom Haviland, who has been raising awareness of this, I've also been following this story. Now, I'm going to show you some images here that are not for the faint hearted. So, if you are struggling, I will just flash it, look away, and I will help you to understand why this is still relevant. This is from Richard Hirschman's X or Twitter, and he has posted it there since about 2023. This is the kind of thing that it looks like. Looks like calamares. This is in formaldehyde. It is very unusual, and they have not really seen it before. And this is not just him. This is globally. This is a pattern that is occurring. So your question is, other than the fact that I regularly raise awareness on this because I try and understand it from multiple points of science, what really am I looking at today? Well, it's a correlation. So what happened is that in the past week, I had an interview with Christy Grace. She is into biotechnology and she's like a whistleblower on what she thinks is a really big problem with regards to the platform. Now, I have to be careful what I say because I am being censored left and right about talking about this. So, this seems to be touching a nerve. So, if you want to understand, what you must do is look in the link below in the description, and you will see this link to look at this interview as well as the details about LNPs, the principle of the ionizable lipids, what happens with temperature, why is it that it hasn't been more thoroughly looked at, and the preprint paper from Christy Grace about her hypothesis on what should happen. It's very important to note that she knows how to research this. And what I'm going to be doing, because I think this is so important, is that it's quite possible that industry may not fund this kind of research and it may need your help. But let's come to that in time. But for the time being, this is what I'm talking about because what she was making reference to in terms of adduction, which I'll explain a little bit about, makes sense in the context as to what could be being seen with regards to embalmers clots. So, this is me now. I'm going to take you through a few scientific slides just to show you what it is that I am thinking about. Okay. And again, let me reference, we're going to see some images that can be a little difficult to look at. So please, if you don't like them, just look away. Remember as well, this is my interpretation. This can't be put forward as a scientific paper. This is just me trying to integrate the science to make sense of what is happening. So let's start with the first thing. These strange clots embalmers are seeing are real. They're not made up. They're not a conspiracy. They are occurring across the world, and many embalmers have seen them. This is Richard Hirschman with a picture of one, which is 19 inches long, in formaldehyde. Fascinating stuff. They're white and they look strange. And these have been analyzed as well by Kevin McCairn and found to be amyloid in their characteristics. So they're very unusual. Now, they're different from a normal blood clot, which would tend to be looking something like this. This is a red blood clot. It's stable, fibrin forms. The whole clot tends to be dark red. It doesn't have any stringy material. And these are standard clots. So the difference is to do with the very fibrous white bits. And again, here is another difficult image. In this image, this was taken from a living person. And so about a year and a half ago, because I only thought it occurred on death, a whistleblower showed the same kinds of clots happening in people in catheter labs. So this is people who have to have clots removed because of very serious clotting issues, like a clot on the lung or something. And this is what it would look like. And this is taken from a living person. And you can see the combination of the white clot, the red clot. This is in the inferior vena cava. Pretty serious. This person managed to survive because it was taken out. But it's important to note that this doesn't seem as though it happens normally. Really critical point. So meaning that we do angiograms all the time, looking for various things. And so we see arteries as well. And they are not, clots of that size would be seen, and therefore that would be an urgent referral to have it removed. So we're not seeing clots of that size normally, unless, as in the case with the whistleblower, they were suddenly unwell and needed to be taken to a catheter lab to take them out. But in routine scans, you don't see that. So this is very important to understand. So here is where I am now integrating two things together. But in order to get it, you have to understand what embalmers do. And essentially what embalmers do is this, is that they have to remove the blood from the bloodstream because it contributes to the decaying of the body. And you can see that they have a pump which pumps embalming fluid in and then takes it out. And it's when they're taking it out that they see all these strange clots. It's important to note that the embalming fluid can be different things, but in this context, I'm talking about formaldehyde. I think this is one of the options that can be used, and I'm using it as a template to explain what I am talking about. And so this is a very unique procedure. Pathologists don't do this to take blood out of a patient, so they would not see this unless they were specifically looking for it. Now, we have had a doctor come forward and say, yes, when he has done autopsies, he has seen similar clots within the aorta or the inferior vena cava. So we know it also occurs in certain situations on pathological examination, but it is not as common. Good. Now, the next point is that when you look at the clot and the mechanism of the clot and the details around it, this is what one of them looks like. And this is where it gets very important. In this is a 25-year-old male who died. And in blue, you see that it's primarily fibrinogen beta. In red, it's hemoglobin subunit beta. Then there's the gamma chain of fibrinogen, the alpha chain, and then the hemoglobin alpha unit. So primarily, fibrinogen and hemoglobin makes up the majority of this clot. We don't fully understand the mechanism of it, but as I said, it has been shown that it is quite uniform and it has uniform fluorescence. Where am I going with this? Now, this is where we're going to link the two things that Christy Great was talking about with regards to adduction and embalmers clots. It's important to know, sorry, I can't say I knew much about adduction until this was shown to me in terms of the research. And I've therefore been applying thought to, okay, what is the mechanism? What can be happening? So let's take you through where I think this is going. This is an image looking at the general premise with regards to an mRNA vaccine. It's a lipid nanoparticle on the outside, and on the inside here is the mRNA. These strands are what are used to transcribe into the spike protein, which then triggers the immune response. They work and they trigger an immune response and they produce spike protein. Fine, that's clear. So, what is it that Christy Grace was talking about? Follow this closely now. So, she was not talking about the mRNA as the issue, she was talking about the packaging. And when you look more closely from this image from Inside Therapeutics, you can see that the lipid nanoparticle has multiple pieces. On the outside, you have phospholipids, you have PEG lipids on the outside, and you have cholesterol. That's the whole outer shell. And then on the inside, you have the RNA strand, and it is supported and protected by these ionizable lipids. Okay? What Christy was talking about was the changes that can occur with these ionizable lipids and whether this can cause adduction. And I'll explain a little bit more about what adduction means when we take it step by step. So hopefully you're following me. And again, this is an image showing, now this is my drawing of a lipid nanoparticle. On the outside, you have the phospholipids, the cholesterol, the PEGs. But on the inside, you have here the mRNA strands, and they are then protected by these ionizable lipids. This is what I'm going to be focused on, these ionizable lipids. And this is what I am tying as a possibility to explain why embalmers are seeing something that in routine work we in the clinical community are not seeing. And as I said, even though it does happen in some living patients, they are usually very sick. But in the average person, we don't see this. So there is something that must be able to connect the two. So follow along. Again, my theory. So here we go, explaining a little bit more. In this case, this is the ionizable lipid. What Christy was saying was that sometimes as the temperature rises, some of these can become positively charged. Not all of them, maybe a small amount, but let's just assume it becomes positively charged. What then happens is that this positive charge can then bind to a protein, RNA, or even DNA. And that's the premise of adduction, because when it binds, it then changes the conformation of the protein. So you will know that in this case, the hemoglobin beta subunit has changed color to mean that it has changed conformation. I've done the same thing here with regards to fibrin, binding again to a positively charged lipid nanoparticle, here, ionizable lipid, and this can then change conformation and therefore change its shape. This is the template that I am proposing. This is the template that I am proposing could be the mechanism related to these clots. Okay, let's step along. So that's the first phase. The second phase is to link it to not macro clots, big clots, but to small clots, what I call microclots. So this is the template for what I think is happening. The first thing that happens is these microclots. So now that you have these abnormal proteins, a trigger of the immune system, and these represents either neutrophils or macrophages releasing nets. And these nets trap these abnormal proteins to make microclots, tiny little clots that are very difficult to dissolve, floating around in the bloodstream. Now, we know this is occurring quite extensively across the population. As to the exact mechanism, we can still argue about it, but we know again that they are amyloid based and they are very difficult to dissolve. Good. Now, this is the link between these microclots and the embalmers. So the two things, I'm taking you on a journey here, follow along. In this case, I am saying that this is now a microclot that could be floating in the bloodstream, could block a tiny blood vessel from time to time and cause symptoms. But it's when the formaldehyde is then injected by the embalmers that we see an unusual response. And this is what I am thinking could explain the premise of adduction and the fact that embalmers across the world are seeing this unusual pattern. So I say that when the formaldehyde is injected, it then accelerates this process with regards to a connection between these microclots. And this is what I think is happening. Suddenly, you have all of these little clots coming together to start forming these macroclots. Now, this has to happen exceptionally quickly because sometimes embalmers have said within hours of them doing the process, they are getting these big clots forming. And so my theory is that you're having now all of these microclots going to little clots, going to macroclots, becoming the genesis of the embalmer's clots. And this, therefore, would be what it looks like. These whitish things coming together, all joined together. The red are the normal clots, the white are the abnormal clots. And this process is, in principle, occurring because the underlying mechanism with regards to adduction is driving this formation of insoluble clots. Now, there is no doubt there is also a link to spike protein and spike protein circulation, and that is certainly the case. The question is, how does it all integrate, and what makes it change so significantly that makes embalmers see it and not necessarily even pathologists? There are a few cases, as I said, where these clots are noted in somebody who hasn't had formaldehyde injected. And so we know there must be other mechanisms where they can form. But as I said, this is me trying to tie two things together that could be very, very relevant. If you've just joined, I am teaching you about this principle of adduction, and you have to look at this Substack article. The link is in the description. We cover quite a few things in terms of lipid nanoparticles and whether or not this can be a trigger for other kinds of things that are relevant. Some people don't like this topic because they say it's unnecessary to look at these things. My view is that if the premise of adduction is occurring, we should want to know what the implications are for health. I don't think it's acceptable the fact that you can use the loophole that because the mRNA are vaccines, they therefore don't necessarily need to go through this kind of adduction check. This is what Christy Grace is saying, and I would agree with that. If we have a mechanism that could potentially explain and drive through our understanding of some of the unusual patterns, I think it's incumbent on all of us to look for answers. So, as I said, if you want to learn more, please take a look in the description. And also in there, you will find the link to the free Humming Heroes book, which you can get. And we hope you can support us by buying some more. Have a great evening. We look forward to sharing some more science in the near future.
A hero, an immune adventure, Humming Heroes, your lyrical guide to the body's defenders. Now on Amazon. Check the links below.